Hello and welcome. I'm Bill Wake. We're here working on a game from the 1980s era in BASIC that we've converted to Swift, and we're at the point of dealing with some magic numbers that are in the code. So we'll do that refactoring to clean that up and some work in, we have a separation between our environment and our application, so we'll do some work on the environment as well. All right, let's go to the code and see where we are. All right, I just ran tests. All is okay. All right, let's see what we're up against here. So I want to start in content view. So we have this notion of the environment that's coming from this basically module. And when we look at the code, what we see is there's like 0 to 23 here, a lot, and 32. These are just kind of magic numbers. I mean, we have more magic numbers. These ones down here are related to the keyboard matrix of the original system, which is, 30 or so, 30 years out of date, something like that. But I'm concerned with these. Here we got 23 a couple times and 32. They're related to the fact that the screen size on the computer we're working with, basically they allocated a screen memory that's like 32 by 32 or 32 by 64, depending on the model. But the visible area is only 24 by 24. So we're showing the stuff that's in the visible area, but we're using these magic numbers instead of something from the library that tells us. Okay, and then in our main code, this is the code we wrote. Well, we being somebody. Let's see, we got some there too. So let's find 22. Do we have some 22s? Yeah. Here we're drawing the top of the grid, and we're not putting anything on the corners. Okay, so it's 1 to 22, 0 and 23 are left blank. So let me run it once. You can see what I'm talking about a little better then. At any rate, what I want to do is get the numbers out and make them reference something about the environment. And in this case, the top, it should be screen width and the side should be screen height. This is probably screen height -1. All right, let's go over here. All right, I hit go. It says hello blocked, and then it's going to draw the lines at the top of the screen and then draw down the sides for the height of the screen, and then fill in a bunch of blocks to the width -2 because we got the edges to worry about. Let's see, we'll get 7 rows of that. That's determined by our app. And then we'll get the ball and the paddle and the game will start. All right, and then we can move. Okay. That blinkiness, that's a consequence of the way we draw our paddle. We erase it and then redraw it. So from a visual sense, that's a little weird. Okay. So let's consider the 22s, 23s. Screen line distance, I think, is a constant for 32. Let's find that thing. Jump to definition. Yeah, 32. Again, 32 is coming from, it's an environmental thing. If we made our screen, 32 wide, then that constant might be different. Okay, row 0 to 6. That's an application constant. Okay, I'm not going to worry about that one right now. I don't know if we have any others. All right. And if we look at environment, so environment knows screen line distance and screen line length. While I was thinking about what we wanted to do, that's probably should not be a constant. It should probably be a function. because I can imagine I would like to have some pluggable environments. If I were doing a Commodore 64 emulator, the screen size is different. It's definitely not 24. If Yeah, same thing. Screen start, screen end. That's totally specific to the model of computer we're working on. Even if something has, memory mapped and all that stuff. Okay. So, well, let's see. How do we want to do that? I think well, if we defined a value, let's do that much. So let screen width equals 24. Let screen height equals 24. We'll just start with this. Okay. And this 23 is the rows, so that's the height. So I'll take dot less screen height. And this one is the column, so that's screen width. And this is screen line distance, 32. All right. So at least we pulled stuff out. So this is a little more generic. Character, environment screen, offset plus row. That's a little awkward. And it seems to me like environment could do the work here. If you gave it the base, the row, and the column, that formula is within its purview. Okay, let's run tests. The way our tests go, we can't really detect changes in this because our tests are focused on the screen, not the UI. So in effect, I don't think this test could fail. I think this is better. The other thing I'd like to do, this bit here, I think this much is, that's something that's sort of generic to the process of having a screen, drawing a screen. It's not something different for each app. Where this stuff down here, this is these buttons, which keys you would hit and so on. This is all based on that. So let's see. Well, we'll get those tests running. We'll run the app manually, and if the grid looks funny, then we would get some indication there. Okay, I'm going to keep looking around while that gets warmed up. All right, yeah, this is that 53381. That's definitely coming from the environment. Okay, now we're going to watch the drawing. Hello is fine. Got that. I'm going by looks. It looks like the same height to me. Things are drawing. I guess we'll give the paddle a chance to be in the wrong column here. Yeah, I think we're fine. Okay. And let's do this. Let's commit this. All right, I think I can do this. I think I can extract this as a method. Okay, and I'm going to call this screen. Okay, I'll pull this down. Okay, and we'll just do a build. What I've done then is I've created a function that has returned some view, and then I used it in here. And that's definitely a style thing that content view is good with. And what it tells me is I could probably make my own struct. I mean, sort of the next stage out is make your own struct. And I think I'll do that. All right, so let's, what do we have to do for this? We don't, where's game? Game run. We don't reference game in here. We do reference these variables that I just pulled out. Nothing else does. Okay, so let's extract a new view. Struct screen view returns, or its type is some view. And it's going to have this thing, which actually I want to be public. And I even want this to be public. Okay, so I've got a function screen, returns some view. Why are you not, there it goes. Some types are only implemented for declared types of properties and subscripts and return types of functions. Well, we have to make this a body. Of type some view. I think the complaints are the fact that we got these things off. Nothing up here should be using those. Okay. We'll define them down here. Oh, I'm wrong. I'll accept the duplication. For the oh wait. That's in there. Okay. It's not the smoothest refactoring I'm doing here, is it? All right, but this should be screen view. All right, what else are we missing here? Char set. Let's find references. Okay. I don't know if we're just still getting a struct content. Oh, it's just of type view. Okay. The body is of some view. Get it right. All right. Environment we don't have. Okay. So we're going to have to pass in the environment. All right. We'll do it the same way. All right. That gets passed in. And we'll need it passed in here. Okay. Body must be declared public. Right. Okay. I think we're there. And this notion of creating little helper objects or little individual views is definitely part of what Swift UI is bringing to the table. Okay, I'm just looking around while that does that. Okay. Now, all right, again, the drawing should look unchanged to us. Draw the tops, draw the sides, draw the blocks. All right, so my mission here at this point, I want to make screen view live over in my library because I think that's where it belongs. So we'll take this, copy it into this thing. Basically, we need a new file. Come on. All right, that's done. There we go. Swift file. Next. Something oddly slow, isn't there? All right, this file is weird. Okay. I'm going to call this screen view. Rename it over here. I want to paste this here. Did I copy it properly? Copy. Paste. Okay. I don't know what's going on there. Is this? I'm in one of those loops where you're so delayed you can't tell if things are on or off. All right. The complaint here. Can't double click. We got some imports to do. I'm just going to try and close that. Okay, let's see what we got here again. Can I find? Okay, there we go. Okay, now I'm going to confuse this thing. Let's see. All right. What I want to do, well, let's put this in the library. All right. So if I commit, and I feel like there's more stuff that has to happen, but let's get this done. Okay, well, we added screen view. me just make sure this is stopped. All right. I don't know what else will be taking too much time. Let's tag this. We're up to 17. Okay. Now we push this, including the tags. Push. Very good. And over here, we're going to update this. You can see the file is there. Hopefully I did enough public stuff. And then we're going to delete it from here. Okay, and then we're going to try and convince this thing like I really did delete it, and you really should include this stuff. And okay, we'll let it finish indexing. Okay, can't find screen. We're going to clean. And then we'll run. Oh man. You found it a moment ago. What's your problem now? This, we made a public struct with a public body. Oh, I always forget the initializer. Oh. Can run these tests, I guess. Oh, what property is not stored? We really don't need to say basically here either. Still trying to test. There we go. Okay. Good. Let's push this. Not sure why that's not saying modified. I'm puzzled. There we go. No files to change. But we're still at 17, right? I don't know. Well, let's... Keep thinking there we go, but no changed files. Did it not add this to the... I don't know what's going on here. No changed files. All right, let's go to the terminal. Oh, no, I have to remember where I put this library. You know, I think it's... The other thing I realized, I've been very negligent on my to-dos. Let me get caught up on that. Okay, cancel this. Well, basically to-do's been over here. We did that, I think, maybe more than one time ago, but we'll just put it on there for today. Is this episode 7? Okay. All right, and so what we're doing is we're move screen view to the library. All right. And the library, oh dear. Did I put it in here? Huh. Okay, I'm clearly not operating where I think I am. Okay, so this thing, source control push. I don't think I have anything to push. All right, let's get this thing to tell us where it is. Show and finder, that's a thing. Basically, Twitch swarmed basically. Okay, I missed it there. Not staged for commit. I don't know what happened there. Usually, I don't know. There are people that love the command line. I'm just as happy to let the IDE do it. But here we are. Okay, let's see if the IDE picked it up. We're here. Screen view. Let's try changed. What the heck? And go here. Let's tag this one. Push. Tags, push. I normally have pretty decent internet. I mean, I don't think the computer's that fast, but this seems a bit slow. There we go. Back here, update our package. All right, let's do a run. So, bottom line of this, screen view is now in the library instead of in this file. I think like that's doing what it's supposed to. It's certainly drawing stuff on the screen, so I think we successfully did that. All right, so commit this. Let's see. Switch to library screen drawing. Okay, let's see what else we got. That's running already. I think, well, that cleans this up pretty well. I guess let's stick with that screen object and let's make it a little better now. And I don't want to make any changes that are changing the impact of it. Let's see. So I'm saying environment should tell me screen height, screen width, and distance. All right, let's do that. Visible screen start, visible screen end. That's all good. Screen line length. Well, this is ambiguous. It really is screen width and screen height. Let's see who uses this. Nobody. Let's make sure. Nobody over here. Let's see about over here. No results. Okay, well, that's something. Okay, let's change this then. Screen width. And screen height. All right, I don't know. Let's see. I guess I want to see what we have here. There's this notion of the law of Demeter, and it basically says, I mean, it's more complicated than this, but if you want something from an object, you should just ask it. You shouldn't ask it for an object you can talk to get the thing you want, or that you talk to that gives you a thing you talk to get the thing you want. And when you have this dot that dot this dot that, it sort of indicates there's probably a violation of that law of Demeter, or Demeter, or however people say it. And what I have here, it's like, really, notice all these things have the same prefix. Well, these aren't even a prefix. They've all got screen, 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 screen. In a way, I could talk about a screen object, and that would be reasonable. But if I did, then everybody would have to go environment.screen.length or width, say. And I'd have this kind of chain of stuff. Instead, I pull it up to the top level, and I'll let you ask, what's the screen height? Okay. Oh. Screen line length. Didn't. All these people that claim not to be using it. Yeah, those. All right. Let's see what they really want. Okay. So this is Okay, this is the print routine, and it's trying to basically break things up into chunks the width of the thing. So let's make it screen width. Okay. The screen end plus the screen line length. Again, I think this is all around the width. And then again, I think that's screen width. Okay. And screen width. Let's just diff this. I think that should be the difference up here. Screen line length 24. Okay. Test should pass. All right. It's time for a break. Let's take 2 or 3 minutes. We'll come back. We'll finish working on these constants, and I think we'll get this exposed as a new field, and then we'll make things work. All right. See you in 2 or 3 minutes. Hi, welcome back. All right, we missed another screen length. Let's see, this is about keyboard row. Print shifts screen up. Again, I think this will be the width. Okay. Quite sure where to put these screen things. Maybe we'll put them up here. There's a lot of talk about screen. So what I want to do is define an int that is the screen width. And I'm just going to return 24. Different systems might have different answers. I'm going to make this a function. Public func. I don't know what int is doing there. Lowercase at that. I guess I'm writing Java. Okay, and screen height. Is also 24. Okay, nobody uses this, but I'm going to take away these variables, and I'll do one at a time. Let it complain. Well, yeah, let it complain. There should be a bunch of places. All right, environment.screen width. And I think I'm making it a function because I can imagine some environments do let you change these things on the fly. So we would oh, do we have an environment? It's just local. We're in the environment. Okay. Because it's no longer a constant. Okay. And I seem to recall nobody was even using screen height. Anybody else now? Tests might have some complaints yet. I think we had one instance in there. There must be a way to tell this thing that, like, build the system, I want to build the whole thing. Not just build the tests if everything else passes. There we go. This is env.screenWidth. Now screen view has an env, so I'm going to take care of the ones in here too. Screen width, and see who complains. They can go to the environment.screenWidth. Same for screen height. All right, let's take these two out. Some more tests. I guess the tests are kind of irrelevant on this one. Okay. Screen line distance. That's another good candidate. Okay. And gonna be a lot of places using this too. Well, the test is still running. Right. This comment I don't think we need to include. Who uses visible count? All right, now I think I want these addresses. Let's see. I guess so. Screen start. Okay, visible screen start, 53381. Okay. And I guess I can comment these and deal with the consequences. Take a little bigger step this time. This is kind of interesting. Failed. No issues. Cannot conform to pointer. Okay. Screen. I think I'm gonna have to initialize this inside. Okay. Oh dear. There may not be a way around this. Okay, I'm gonna make these private. So this is going to return screen start and screen end. All right, run tests. I think there's going to be an error or two in the test too, though. Compiler errors, that is. Okay. Static member screen start. Oh, I guess I gotta be specific. Tests, yeah, good. So this is env. Oh dear, something's crazy. Still build. I don't know. Something's something's not working on this editing. I should be able to type in here. Faced with I think that'll give us enough of a batch to change. It's very odd. It's in a light gray instead of the right way. Okay. Let's let that finish running. Okay. Okay, there we go again. All right, so change constants to be functions. Oof. Screen constants to be functions. Okay, we're one ahead. We'll tag this with 19. And push. When I update the package, I expect everybody who was using those constants to start complaining. So we'll just change those to the functions that use them. All right. Update the package. Now maybe the screen should come out as a separate object, not visible to the client, but used internally. I mean, the screen is definitely a different thing than the keyboard and the whatever's. All right, so it's updated. I am going to say a lot of stuff's going to complain. And what do we say our to do? Move screen view to the library. That we've done. All right, what we're doing is environment functions to get screen, well, constants, screen related sizes. I think that's accurate. Now, really, nobody ever referenced that thing, so it's probably our raw constants down in the other file. Where's blocked? Oh yeah. Okay, let's find usages of this. All right, now I think we have environment, right? Yes. Okay. So, did we put screen line distance in there? Yes. Okay. So let's use it. $54141. I think our number was 5414. O. Right. So I think that actually, well, okay, let's go back to our picture. If you haven't seen this, look. Okay, so this is the visible screen area. 53381 is the top left corner. 54140 is the bottom right corner. This number in this column is the cell after the visible screen area. I don't know why. That seems confusing to me, but, well, it certainly confused me because I kept assuming it was right and then finally realized, like, hey, wait a minute. 7, 8, 9, 21, 22, 32, 37, 38, 39, 40 is the actual ending of this thing. So I don't know what we're doing with this constant. We're probably doing the 54141. We're probably doing, you know, up to less than, but maybe the code assumed it was the right place. I don't know. All right. Screen top left corner, that is what we're calling visible screen start. Okay. So this is environment.visible screen start. Let's find it again. Top left corner, top left corner. All right, nobody's referencing that. Let's find this. Less than or equal. Okay, what we see here, if the ball is less than or equal to the bottom right corner, well, that's actually a mistake. Okay. If it's less than or equal to 54141, it's over here, which is completely out of range. All right, so let's make sure we're building or running. I don't know if anybody else, yeah, nobody else was using this stuff. Okay. Now, I think in a way this equal to the bottom right corner is sort of a can't happen thing, because the only way you would get there is you'd go down, you'd have to move over by 1 basically, because you always move by 1. So I think while the ball is less than or equal to that, it really is while the ball is less than screen bottom right corner. So I'm going to change this, and well, what am I going to do? I'm going to claim that this really is, I don't know if it's exactly a bug. I don't think it would ever manifest itself, but it's really thinking about it wrong. The ball should be within the ranges of the visible screen. If it's not in the visible screen range, it went flying off into nowhere land, and that's a problem. All right, so if it's less than or equal to, I think if we take the visible screen, we will still pass our tests. Now, maybe our tests aren't good enough to get it. I can't tell you that our tests will necessarily catch it, but I'm pretty sure you can't tell the difference. So, all right, so I'm substituting environment.visible screen end, isn't it? This. Okay. Now, again, it's 53140 over there and 53141 over here. wherever it went to. Screen. What was the name of that thing? Where is it? Bottom right corner. Yeah. Let's see who else is calling that. Nobody. Okay. So we're putting in a different value off by 1. Let's make sure it still runs. Yeah, because if you think about the motion of the ball, usually it's going to be going down and left or down and right. And if it's on the paddle row and it goes down a row, then it's definitely outside this visible screen area. There's no off by 1 error there. If it goes to the right 1, it's going to hit the wall, and so it'll never get below that wall. I mean, the way our code is, it only lets you move to a blank space. So in principle, I don't think you can ever get to that. You can never get exactly on that cell even, because the walls are there. But, you know, you could make a mistake in the walls and all that stuff. And if you did, you'd want to make sure you're not in range anymore. Okay, we're testing. Okay, so we're let's see, I guess this is changed bounds on ball and range test to correct value, but wouldn't cause a problem either way. Okay. All right, what else we got? Okay, I don't think we have any more 32. Oh, we got space 32, but that's not the same. Space, no 32s. Let's try 24s. 23. Okay. Here we go. And 22. Okay, so 23, drawing the top, this is the number of columns minus 2. So it's env dot a screen width minus 2. Let's put this here. Screen width is 24, minus 2 is 22. Okay, now this one, this is the rows. So 23 is visible screen height minus 1. Okay. And this 23 here is back to the width. Okay, so this is env.visible screen width minus 1. 24 minus 1. Okay, and then finally, drawing the blocks. Well, again, this is a function of screen width. It is env.visible screen width minus 2. Okay, again, the blocks can't draw on the walls, so they have to go in a little bit. Okay, so I think we've gotten rid of our 22s, our 23s, and our 24s. Okay. Okay. Let's run tests. Oh, we got a 25. Well, this is a clear screen thing. I guess we can say it's the screen height plus 1. Uh, 0 to 20, 1 to 25 is the same as 0 to 24 because we don't use the value at all. Okay. And then let's do env.screen height. Visible screen height. All right. Oops. Environment has no member visible screen height. I guess that's just screen height, isn't it? Makes me think we're not being consistent here. Okay. env.screen width minus 2 dot for each. Let's see, env screen width parens minus 2 parentheses to there. That seems correct to me now. env visible screen height minus 1 parentheses. Yep. Oh, but it's called screen height. Screen height. Okay, let's try it again. Explains why it never suggested those when I was expecting it to. Screen width, and we'll run tests. All right, well, this is a good time for another break. So while those tests are running, let's take a 2 or 3 minute break again. See you in a few minutes. Welcome back. All right, the test's finished and passed. Let's commit this. And I don't think it would hurt to compare. All right, so we got rid of these constants that we can look up in the environment. We're using the environment in each of those. Same thing. Okay, let's commit. All right, so what, whoops. Let's see, we updated to use environment screen sizes. All right, seeing my confusion there makes me think visible screen start's not a great name. And I want to do this in 2 phases. I think screen start is probably the name I should use. So screen start, line height, width, line distance, those are all kind of accurate. I think this screen start is really absolute screen start or something like that. It's the address of the memory area that the screen is allocated in, where the visible screen start is the address that we start with, that we can first see visibly. In some systems, these two will be the same value. So I don't know. I'm thinking absolute. Maybe it's like screen memory start, screen memory end, and this becomes screen start, screen end. So let's try that. Let's make this screen memory start. Let's see. Oops, come on. Rename. And I'm going to do it in 2 phases because I want to change the other ones to screen start. But I don't want to break things, because I get confused if they both change at the same time. So I'm going to have to do 2 releases, unfortunately. Screen memory start and screen memory end. And I think I don't feel bad about exposing that concept, because part of understanding the way these systems get programmed is like you are manipulating the screen by poking into memory. And if that you realize that is critical to certain things. Okay, so I will run tests. There's let's see, I gotta do this trick every time. Where do you set that? I don't know if this thing works the same. With this package library. See, you can turn off the debugger in your tests and it runs noticeably quicker. You got to turn it back on to run the debugger. But env screen end. I don't know why this didn't update. No, I thought I would get some little marker when something was changed from the source control point of view. Oh, what is going on? Okay, we definitely touched a test and the environment code. Screen memory start, screen memory end. Okay, can I refresh? I don't see it. It's on file. Well, all right, we got the tag 20. Let's push. With tags. And I don't even know if this thing uses, let's see, screen start in project, ignoring case, yes. And preview content. Visible screen start, visible end. Okay. If I don't reference it anywhere, then I guess I can continue on. I should have checked that first. All right. Well, since we're here, let's update. Let's make sure the build actually catches it. I've had too much flakiness in dependency checking. Okay, there's 20. Let's run tests. While it's going, we can modify our library. Environment. Visible screen start, we'll rename. To screen start. Screen end. Oh. Probably just canceled my tests over here. This really belongs down there. Okay. These tests are happy. Let's do this dance again. Okay. Visible screen start and end to just screen start and end. We'll just wait for this to push. I wonder if I should just be doing this all locally. Save myself a little grief. I noticed my tags. They probably should be 0.0.0. something, shouldn't they? All right. 21 is our new version. Now, when this comes in, we expect things to break because they said visible screen start or end. There we go. See if any tests use the variables. Successful. Okay. Run tests. Assuming everything's okay, I think we'll take a quick walk through, just kind of see the changes we made, and then start something a little new. The thing I have in mind to start is, I have complained about it before, but the way the buttons are now, you hit the left arrow to move left, and it keeps moving left until you hit either the right arrow or the stop arrow, which is a little V. Okay, so you either tell it keep moving left, keep moving right, or stop. Really what I would like is press the button while it's held, you're moving left, while it's released, you're not moving. And we took a quick look at how do you do this in Swift UI, and it looked ugly. Ugly for me is like more than 2 lines of code. You know, I just want to plug in something and it works for me. But apparently this one is not that simple. Now, I know we changed code. Xcode is just losing its little mind. All right, let's go back. Those are a little questionable whether I want those. Let's see. So we updated to latest library. Use screen start and end. Okay. Okay, so what we did today, well, this is not content view. There we are. All right, so when we started today, we had this content view knew all about the screen, like how big is it, how do you walk through the pieces, and so on. And we pulled that out into the library. So now the library just says, I know where screen memory is. I'm just going to dump it out, rows of columns, show you every character, and that's what you get, which is pretty much what we're going to want in most of the cases we're working in. The stuff around this is those arrows I mentioned. You know, it simulates a key, whatever keystroke is key left, stop moving, key right, and a jump that says add some jitter. Okay, but those are definitely dependent on the particular game. I mean, there's code in our game that looks for these particular flags or values. Okay, but the rest I think is okay. And the screen view being its own struct in the other place. The other thing we did a fair bit of is you see a lot more env dot screen somethings now. They used to have some constants defined up top. We still have a bunch of constants, make no confusion about that. But all the things around the screen height, width, and the line distance are all out of here. And that's a good thing. Okay. This, I almost think environment should provide a clear screen, and then we could just translate that and be done with it. Anything else visible here? Not too much. Okay, and then in the library, we didn't touch basic support. We really did focus on the environment. So mostly we had variables for these things. Now they're all functions. I think it conveys the more accurate perception that these could change. In OSI, well, if you have the 24 by 24 screen, they won't change, but you could have a 32 by 32 or 32 by 64, and they would change. So in some systems, like Commodore 64, I'm pretty sure you can change where your screen start is, maybe even where your memory start is and stuff like that. You probably can change stuff on the fly. So the fact that these are functions that could give you a new value based on the current settings, that's probably a good thing. All right. I still think there's some ugliness around this, or there's something going on here. We didn't touch peek poke or any of that. We touched print just to kind of introduce the screen line distance and width calls. All right. So that's what we've done today. The rest of it, we're going to start the experiment of how do I get better arrows, better movement. Okay. And I want to move away from this keyboard simulation completely. Okay. That's, the keyboard's pretty irrelevant to the typical iPhone or iPad app. I mean, they use the keyboard for some things, but in most games you don't have a keyboard. You just have buttons for the critical stuff. All right. So let's go to the good old search. Okay, and the search we were trying is about Swift UI detect button up. And maybe it's detect button down too. Long press button. How about detect button released? If I could spell. How to detect key presses and release in Swift UI. I think we were here at one point. Oh, this one's on Mac OS. Yeah, so that's an example of too complicated for what I want to do. Fire event, the user stops the long press. Okay. On-ended fires when long press gesture is detected. Oh my goodness. Yeah, this is the kind of solution I just don't want to do. Detect the touchdown events. Use a custom view modifier. On touchdown gesture. Is there an on touch up gesture? This is on button. Action that. I don't know if there's non-touch up gesture. That would sure be handy. Okay, let's see if this runs. No. Button of text has no member on touchdown gesture. Now why did his code button action color.clear? Fire action after release button. Well, are you saying there's, now you're saying there's no errors? Button text has no member, so can I do this? I don't know what this extra thing was in his code. Let's go get help on button. An action and a label. Action and a label. Why do I have label and then action? That's this one, key and action. So on touchdown gesture. No on touch. Sorry, let's see what that was again. He does button action and then contents. I don't see why that should matter, but we can do it. I think I don't need this in this case, but I do need the contents of the button. No. Action colon. The other thing with these kind of answers, like things change in this environment. You know, Swift UI is new. Swift is fairly new. Let's see some ons here. On tap gesture. On receive. On hover. Certainly not drop. Long press gesture. Button action. Yeah, I just don't think that code's compiling for me now. Okay, let's go back. Now I know I was in this article before. I think yet another solution I didn't cotton to. Touch up inside, touch down, touch up outside. Yeah, that's all good stuff. I only got one touch up inside. Okay, I want to know about touch down. Okay, button press, do this. Button press, toggle. Right. Press down to accelerate, release, slow down. Yes, that's what we want. Okay, we have to have a gesture state. Excuse me. All right, the closure gets passed around. We'll update the button state every time your finger touches down or up. Change state is a function. Okay, so we've got a drag gesture, minimum distance 0. So I guess that's just detects a touch. Updating is pressed. Gesture equals true. I don't know what gesture state is. That just looks... Oh, okay. It was passed in. Gesture drag on change. Change state pressed, not pressed. Okay, we'll pick up here next time. We'll try and implement this. We'll see. All right. Thanks for joining me. And next time is Friday, 1 to 3 p.m. Eastern Daylight Time. If you're interested in some of the work I'm doing writing-wise, xp123.com. There's a mailing list you can sign up for there, get notified about new articles each week and sometimes little bonus handouts and stuff like that. So hope you can join me in the future, and thanks for joining me today. Take care. Bye-bye.